As we've seen, a run cycle differs from a walk cycle in that one presents moments of suspension, the other moments of double support. In no way do these two cycles differ in terms of speed. That would infringe on the right to walk fast or run slowly. That said, the advantage of running is indeed to allow those who wish it to go faster than by walking. To do so, one can either lengthen the stride or increase the running cadence. If we focus on cadence, we could, as a first approximation, make do with the 8 main poses of the cycle, 4 per step. However, at 24 drawings per second, 4 poses per step yield 6 steps per second. The best sprinters can't manage that, but that's because they are simultaneously trying to lengthen their stride. If, on the contrary, they shortened it, such a cadence would become possible. But they'd lose the race. If we subdivide the cycle in two, that is, insert a drawing between each main pose, we get a 16-frame cycle, 8 per step or 3 steps per second. This time, it's a bit slow for a good sprinter. This cadence is better suited to a long-distance runner. Subdividing by 3 gives a 24-frame cycle, 12 per step or 2 steps per second, the Sunday jogger. Longer cycles can be considered. However, the longer the suspension duration, the higher one must rise, according to Newton's law. In animation, a character can be lifted into the air as high as desired. In reality, a runner will struggle to reach 50 cm in height, and per Newton's law, that height determines the maximum suspension time, about 16 frames, 8 to rise, 8 to fall. This duration is achieved with a 32-frame cycle, 16 poses per step, 15 in suspension for 1 in support. However, a single support pose assumes the runner bounces like a ball on contact, which is unlikely. To reach such a height, the cycle duration must therefore be further increased to allow the runner to sufficiently cushion the fall, then propel themselves. Let's return to the idea that running is for going fast. The sprinter's base cadence is 4 steps per second, or 1 step in 6 frames, or a 12-frame cycle. 12 refuse to play by the 8 main poses rule. A 12-frame cycle means 12 main poses. This contradicts what we've seen about setting up a cycle, but it's nevertheless a reference to keep in mind. Indeed, 2 steps in 12 poses means 4 steps per second. At 2.5 meters per step, that's 10 meters in 1 second, or a speed of 36 kilometers. 4 steps for 10 meters in 1 second means 40 steps for 100 meters in 10 seconds. This model represents a bar that a sprinter must go under to be among the best. In reality, cadence and speed vary during a sprint, but let's set that aside. Consider instead that the animator is bound by no model. They can achieve 10 meters per second in many ways, by absurdly slowing the cadence or by pushing it to implausible speeds. In animation, anything is possible. Let's return to credible movements. For a run, it's good not to stick to multiples of 8. Any even cycle lengths between 12 and 24 yield interesting cadences. It's an opportunity to practice more delicate subdivisions. Let's see how we could say that a 50 cm suspension could last 16 frames. For this, we'll use Newton's famous formula, which calculates height as a function of duration. H equals half g times t squared. H is height, g is gravity, t is time, squared. It's precisely the time we need to find, with height given. By rearranging the formula, we get the one to find t from h. T equals the square root of 2h over g. Let's keep these two formulas in mind. The first calculates height from duration, the second duration from height. Replace the symbols with the values we know. We know the height, half a meter. We also know Earth's gravity, 9.81 meters per second squared. We can round to 10 meters per second squared, it's close enough. All that remains is to convert this duration to frames. Knowing one frame is 1/24th of a second, multiply the result in seconds by 24. This duration, necessarily rounded to the nearest frame, applies to the upward motion. Doubling it gives the full suspension time, or 16 frames. It's an approximate value, but sufficient for credible motion. Be careful not to deduce that doubling it will double the height. Doubling suspension duration quadruples the height. Finally, observe this sprinting animation. It contains 3 suspension poses, indicating a duration of 4 frames, not 3. The runner rises over 2 frames, descends over 2. 2 frames give a suspension amplitude of 3.5 centimeters. This isn't the total vertical amplitude of the cycle, to which must be added that needed for cushioning. But we now understand why, the faster one goes, the more the body's motion tends toward the horizontal. For those allergic to mathematics, remember that, in animation, no one is required to respect physical logic. However, animating as one wishes while knowing what one is doing is always better.